First, we're going to have a review of some basic math facts. A power of 10 is a number expressed as an exponent of base 10. The exponent indicates the number of decimal places you are to move the decimal point to the right or to the left. If the exponent is positive, then the decimal point is moved to the right. As an example, if you have a number 10 to the third, in the expanded form would be 1 times 10 to the third. Since the exponent is a positive 3, move the decimal place 3 places to the right to express the number as a regular number without the exponent. So for instance, here is the 1.0 times 10 to the third. You're going to take the 1.0, so the point is after the 1, and because it's 10 to the third, you're going to move this decimal point right here 3 places over, which means you have to add 3 zeros. So the new number would be 1,000. The number 10 to the minus 3 in the expanded form would be 1 times 10 to the minus 3. Since this time the exponent is a negative 3, you have to move the decimal place 3 spaces to the left to express the number as a regular number without the exponent. So again, here is it's 1.0 again. So there's the point to the right of the 1. It's a minus 3 power. So I take this, I go 1, 2, 3. So now I have to add 2 zeros. So the new number would be 0.001. In electrical work, the numbers that are multiples of 3 are primarily used as powers of 10. So for instance, here's a chart here. This will also be in the book. 10 to the positive 12 is a tera, 10 to the positive 9 is a giga, 10 to the positive 6 is a mega, 10 to the positive 3 is a kilo, 10 to the minus 3 is a milli, minus 6 is a micro, minus 9 is a nano, minus 12 is a pico. On your keyboard, you can use, for micro, you can use a U to express it. So the 3 steps to change a number from a regular number to a number expressed as a power of 10 are as follows. So first I'll go over the steps and we'll do an example. Step 1 is express the number as a number times 10 to the 0. Anything to the 0 power is 1. So when you multiply something by 10 to the 0, you're not changing the number, you're just expressing it a different way. On a new line and under the 10 to the 0, write the new exponent. Step 3, if the new exponent is larger than 0, it is an increasing exponent. Therefore, do the opposite to the whole number, meaning decrease or move the decimal to the left by whatever the difference is between the 0 exponent and the new exponent. If the new exponent is smaller than the 0, it is a decreasing exponent. Therefore, this time you're going to do the opposite to the whole number by increasing or moving the decimal to the right by whatever the difference is between the 0 exponent and the new exponent. So why do we need to do this? Well, lots of times we have a number and we have to express it in a different form so that we can use one of the metric prefixes. For instance, this one already would be using a metric prefix, but let's say we just wanted to express it as a number times 10 to the third and as 10 to the minus 3. So the number that we have is just 2.356. That's it. So it would, in terms of dollars, it would be $2.35 or 36 cents. But now I want to take this number and I want to be able to use a metric prefix with it. So I wanted to say, okay, what would that number be if I multiplied it or expressed it as a number times 10 to the third and then as a number times 10 to the minus 3? So remember, the value of the number is not changing, so it's still going to end up being $2.35. We're just expressing it a different way. You could relate that to, if you had $2.35, you would have 2 $1 bills and a quarter and a dime. Another way to express that would be to have 235 pennies. So you still have $2.35. One way is you have $2 bills and a quarter and a dime. The other way is you have 235 pennies. So this is the same kind of thing. So we're going to take step 1. You take the 2.356. Because it doesn't have a number times 10 already, we just say it's times 10 to the 0. And again, this is just 1, so it's still the same number. The next thing is we're going to write the new exponent underneath the 10 to the 0. So first I want to go to 10 to the third. So I compare the exponents. I'm comparing the 0 with the 3. So the difference between the 0 and the 3 is 3. And from 0 to 3, 3 is a bigger number than 0. So that means I have to do the opposite to the whole number. I got to make this number smaller. It's always the opposite. When you go from a lower exponent to a higher exponent, you have to make this number smaller. Okay, so and by 3 places. So the point is right there after the 2. So move it over 3 places. So it's 1, 2, 3. I've got to add 2 zeros in front of it. So the new number now becomes 0.002356 times 10 to the third. So again, it's the same number, it's just expressed a different way. Now let's say I want to do it as times 10 to the minus 3. So again, I start with my 2.356 times 10 to the 0. This is still the same number, times 1. I write my new exponent underneath it. I compare the exponents. So from 0 to minus 3, it's still a change of 3, but this time I'm going smaller. So I have to make this bigger by 3 places. So there's my exponent here. So I move it over 3. So it now becomes 2,356. So the new number is 2,356 times 10 to the minus 3. Both of these new numbers still retain the value of 2.356. If the number to express already has an exponent other than 0, just rewrite the number in step 1 and continue with the remaining steps 2 and 3. So for instance, the first number I gave you, 2.356, didn't have a times 10 to it. It was just 2.356. But this time I'm starting with the number 455.67 times 10 to the minus 3. And I want to express that as a number times 10 to the third. So I rewrite the number 455.67 times 10 to the minus 3. I put the new exponent underneath. I compare the exponent, so I'm going from a minus 3 to a 3. So on a number line, the minus 3 is over here, then you go to 0, and then the 3. So that's a difference of 6, and it's an increase of 6. To go from minus 3 to plus 3 is an increase of 6 places. So I do the opposite to this, meaning I decrease it. I have to move this over 6 places. So there's 1, 2, 3, 4, 5, 6. So I have to add 3 zeros in front of it. So the new number is going to be 0.0004556 times 10 to the third. It's still the same value of number, it's just expressed a different way. Mathematical calculations using powers of 10. So now I have numbers expressed with powers of 10s, and I want to do math. I either want to add, subtract, multiply, or divide. Addition and subtraction. Convert the numbers to be added to a common power of 10. You add or subtract the whole numbers, and then you write the whole number with the common power of 10. So for instance, if you have, let me get back up here, I add the number 65.3 times 10 to the fourth with 34.33 times 10 to the 6th. So when I look at these numbers, they do not have the same exponents. I need to change them so they're the same. So I can either make this one a number times 10 to the fourth, or I can make the 64 or 65.3 a number times 10 to the 6th. So arbitrarily, I'm going to choose to convert power of 4 to a power of 6. I'm going to the power of 6 because of the metric prefixes, powers of 3. So I rewrite my number, 65.3 times 10 to the fourth. I put the new exponent underneath, 10 to the 6th. So it's going to be 65.3. I compare my 4, my 6. That's an increase of 2. I need to decrease the 65 by 2 places. So I move it over. So this now becomes 0.653 times 10 to the 6th. Now I can add the whole numbers. So I add the 0.65 with the 3444. That gives me 35.093. And then I just bring down the power of 6. Rules for multiplication are a little bit simpler. I just have to multiply the whole numbers and add the exponents. So I don't have to do any changing here. So if I have 4.5 times 10 to the minus 2 and 5.3 times 10 to the minus 3, I multiply the 4.5 with the 5.3 to get 2385. And then I just take the minus 2 plus the minus 3 to get a minus 5. So there's my answer, 23.85 times 10 to the minus 5. Rules for division are similar to multiplication. I just divide the whole numbers and I subtract the denominator exponent from the numerator exponent. So I have 25.4 times 10 to the 6 divided by 5.2 times 10 to the minus 3. I take the 25.4 divided by 5.2. That's going to give me 4.88. And then for the exponents, I have a 6 minus a minus 3, which gives me a plus 9. So the answer is 4.8 times 10 to the 9. And as a special note, a double negative occurs when the denominator is negative because you're subtracting the denominator from the numerator.